Thanks. So, this is the outline of the presentation. First, I will say why Clojure and why Java. Here we have Python conference, so that's not completely irrelevant. Then I will show you just some feature of Clojure, because it's quite different from this, and it's also quite different from other programming languages. So it's interesting to see just a few features. This won't be a full talk about Clojure, of course. Then I will introduce Java and Clojure interoperability and vice versa. Okay? So, no, that was another version because I had to show some Java code, which is to be dealt with carefully. Some people get offended when I show too much Java code. I removed that from the presentation, so that's not true anymore. Besides, no doubts were harmed during the making of this presentation because we have to do just with dynamically typed languages, so that's easy. And I go this way, okay? So, here we have Java, which is a Python implementation in Java, which runs on the Java machine. Here we have Java, which is the main language of the machine. But nowadays, they are adding support for other languages, and third-party developers are using Java as a basis for more languages, even more languages. So we could have put here basically everything, Scala, JRuby, whatever. Unlike Clojure, it's interesting because it suits well to some problems which maybe you prefer something different from Python, for example, something more functional. But and it has an excellent interoperability with the machine. So, Clojure. Of course, Clojure is mixed, and it is global list, but it's not common list, and it's not scheme. In fact, it has a quite more functional approach than regular common list, in the sense that, for example, state is almost banned. State change. In common list, you can just change the state of variables as you do in regular imperative languages, even if perhaps it's not recommended every time, but if you need it, you can just do it. In Clojure, you have to deal with it a bit more carefully. Perhaps this is the reaction towards the very stateful model of the Java language, which is underneath. Okay? By the way, Clojure is not a pure functional language, so if you're thinking about a scale, that's completely different. You can print about everywhere, and so that's not a problem. The two languages have very, very different approaches. Java is just used for the implementation of Jython. Okay? So Jython is Python, it's meant to be Python. You have to be able to run Python programs. The only thing that you can do, which you can't do in regular Python, is just called Java libraries. That is to say, you can just import Java classes, Java packages. That's it. But it's Python. On the other hand, Clojure is new, it's completely new, and it was built on the Java virtual machine from the ground up. So, design choices match those of the machine, and somewhat this feature is better in the sense that you can call and be called from Java more easily than you can do in Java. And Clojure, besides, has lots of nice features. It's a functional languages, which is something I like as well. Then it's lazy. We have that in Python as well. We have generators. They have lazy sequences, which is something similar, even if you create those lazy sequences in a very different way, but you use them almost in the same way. We have full macros here in Clojure. That is, you have the same power of list, unhygienic macros, for those who know what I mean. And that is a great way to extend the language. That is perhaps the main reason why we want to use Clojure instead of Python if you have to interact with Java. Because with Clojure you can just extend the language, which is something you can't do easily in Python. Well, in Java. It has multi-methods, but we can have those as well, just with a library in Python. Then in Clojure, types are mostly immutable. The lingua, Clojure lingua is we have persistent sequences, which doesn't mean persistent in disk, but just that are immutable. Okay? We have software transactional memory. So the memory works like the D. We just don't have durability. But apart from D, we have AC. Not AC, but AC. We have transactions, okay, so you can update the state in a transactional way, which is, I think, great. It's the only way you can change the state of variables. We have also a nice concurrency model, which is not thread-based, but uses transaction and immutable types to obtain high levels of concurrency on the Java virtual machine without directly working with threads. And all these good things, we won't see any of them. Perhaps just a bit of laziness. We will deal with the bad parts, which is Java. The interoperability with Java, which is what we need to have it call back and forth from one. These are some basic types. There is nothing very important here. Floating point, ratios, big decimals, strings, okay, that's trivial. This is just more interesting. These are the sequences, which are, as I say that again, are not mutable. And it's also one of the main differences with regular lists, with regular common lists and scheme. In scheme, you don't have syntactic support usually for hash tables, okay, and limited for vectors. In Clojure, on the other hand, all those types have got support in the syntax. So you can just write vectors with square brackets, and with braces you have, this should be a dictionary, a map, not backward, it's okay? Like this. And with a hash before, it's a set. So those are types primitive in Clojure. And of course they are persistent. And they also implement the corresponding Java interfaces. This is very useful because Java knows how to deal with these things. And so when we give Java Clojure vector, for Java it's just a list, so he knows how to work it out. And this is the first example of Clojure code. This is a famous example that was on Little Skimmer, one of the first recursive functions. It just takes a sequence of elements and removes the first instance of A. Okay? Lat here is the sequence. And it's a recursive definition. So if the list is empty, then return the empty list. If the first element of the list is equal to A, then return the rest of the list because we are removing that element. Okay? And otherwise, we just return a list whose first element is the first element of lat, and whose rest of the list is the render function applied to the rest of that. Okay? That is, I think, quite easy. And well, here we have the example, which I call on the graphic of Clojure. This is a bit more complicated, okay? That removes all the occurrences, so 4 is removed even at the end of the list here. Here we define an inner function, basically, like having a nested def. And this is a keyword which is different from what list does things and from what scheme does things. Scheme optimizes the tail call of a function because the standards requires that. Common Lisp implementation usually do that. Java does not do that. Python does not do that. Clojure, if you specify that, so you, instead of using the name of the function, you explicitly use recur, and that is the last thing the function does. Take call optimization is performed. What means? When you call functions, you put function frames on the stack. Okay, they contain local variables and that stuff. But if the last thing you do before returning from a function is calling another function, then you don't need to put another frame on the stack. You just can basically override the last frame on the stack with the new values for the new function. So when you use this in Clojure, you use a constant number of stack frames. And that is the reason why in Python you can't use recursion. Well, you can't, you should not. Because if you recur on sequences with many elements, you run out of stack space, and the interpreter blows up pretty badly. In Clojure you can do that, provided that you use that keyword. Okay? So for example, this is basically a generator which returns all the natural numbers, but will take just the first 10. Okay? But we call one record of that, but that does not. Okay? Because even though we don't blow the stack, of course, it's an infinite sequence. Okay? So we would need a Python generator here. If you in Python you want to perform this kind of stuff, use generators. And in Clojure you have to use less sequences, so you can't do that. Okay, you can just do that. But in Clojure it's quite easy. You can just put wrap the outermost expression returning something in the Lasagne macro. This is basically the very same code here. I just wrapped it with Lasagne, and then it works. Okay? That is the only cool feature of Clojure I am showing you today. Now we dig just Java, Python, and Clojure together. So, before introducing more Clojure, I have to show you the namespaces. This is a namespace declaration. In Clojure, you can put more namespaces in the same file. In Python, one file is one namespace. You define things in the file, okay, and they get defined in the module, okay. In Clojure, you can put more namespaces in the same file, but that's not very important. Here, you do something which is like doing an import, so you can use things defined here, for example. You can do a named import that is like as in Python, basically. Here you just import all the things which are defined here, that is the start import. And here you are doing from import, from Clojure string import capitalized, basically. And here you're saying from Clojure string import everything but capitalized. Okay? That's it. And that is for Java stuff. Here we compare how we call Java methods. Basically in Java we just call things like they were Python objects. Okay? In Clojure you have the new macro which returns a new object. Okay? Then we can also place a dot after the name of the class, and that works as well. Like here we can just put the dot before the method name, and that is a method code. Okay. This is a public number, like a constant, for example, and this is a static method. That is the sequence. And here we are starting to show you how to generate things which works with Java. That is the proxy macro here. If you know a bit about string, this is familiar, I think. We have a JFrame, the J button here, and we put an action listener attached to the button, so that when you click this method is called. In Clojure, in Java, we can't just pass functions around, so we have to resort to classes, basically, objects. And that works. This is very dynamic. And is a true proxy. That is to say, here we are just updating the action perform method. So if this is a proxy in the sense that we can change what is tied to the methods. Here we are just overriding this method here with this method here. Okay. And now this is important because it substitutes Java anonymous classes. But in Clojure, we can also define full Java classes, and I'll show you how. Why this is important? Because Java is able to call Java classes. So if you generate the Java class in Clojure, then you can call it from Java. So we have to define a namespace here, and when we use the genClass directive here, this means generate code, generate Java code, which represents this class, and we can call it from Java. So we specify the name of the class, we say which objects it extends, and which interfaces it implements. Here is the empty list. And here we say which methods are implemented in that object. We have to be pretty specific about that, because real Java code is generated here. We have no runtime stuff which tries to do fancy things. It's just plain old Java stuff. This is static, this is a regular method, that is the method name. These are the arguments. So it takes just a collection, and here we return an integer, and here we return void. Okay? And then we have to implement the methods. Those two are the methods implementation. The default is that when you place a dash before the method name, that is the Java method. Okay? So that is the static method, that is this is the static method, so know this here. And this is the instance method. So we have this, which basically works like self-impile. And we call them like this. We import example, and we can call the static method like if it were a Java static method. And here we create an example in Clojure, an instance of class example in Clojure, of the class example Clojure objects. Okay? And we call methods, and here we are passing a Java list. And it works, because it calls count here, and it works. Here I implemented show as a pure Clojure function, which is called by Java method. So, in the last slide, we basically wrote a regular Java object in Clojure, and I show you how to call it in Python. Now, we extend Java in Clojure. That is to say, we are extending an object in the Java code, which is by object, that is, the Java object represents object in Java. So we expect these things to behave like Java objects. Okay? We extend this one. Then I decided to implement this interface because this immutable list for Jython, I want that Clojure can use it as well. So since it is a list, we use that interface. Here we specify that this thing has state, which will be the instance of the list, and we put the state in a variable called state. Here we specify the initializer. The return value of this expression will be assigned to state. Since this is not something which can be used through software transactional memory, this is truly immutable. You can't change that once you build it. Okay? So you take a collection, a Java collection, and you apply the list function on that collection, and it returns a Clojure list. So state will contain a Clojure list. This means about subclasses. I mean, we have immutable list, which takes a collection, and we want to say that when I create an immutable list giving you a collection, you have to call the empty constructor of the superclass. PyObject has got a constructor which takes a PyType object. So since everything here is dynamic, the problem is that Java will try to pass the collection to the constructor taking the PyType. So it's an error, a runtime error. If you want to avoid that, you just tell it, no, this has one parameter, but you have to call the one with no parameters in the superclass. Okay? Now we can just create the object passing a Jython list here. Okay? And now we define all the methods in our system list. Those two are easy. There is a cons method which calls cons on the state object, passing it other. Okay? I suppose that this is a mistake. It should be the other way. But anyway. This is equiv, which is basically this. The equiv method is called when I use the equal sign. Okay? And then I should have done things like that for all the methods defined in the interface. But I did not want to. There was a lot of boilerplate code. So what I did, I created this macro which delegates. Basically here we say, when I write delegate to state, for example, peak, you instead evaluate this thing, which is definite. I put together the symbol, the dash before the symbol, and I create a new symbol here. And it's like if I wrote, that is the meaning of this method, definite, the name I create here, this, and then the name of the symbol, so for example, cons here, state. So these things just generate the methods which I need to implement interface. I could also have wrote just delegate to state and then a list of things, but that was harder to see the macro. Here, I mean, you just see definite, name, arguments, return value. Okay, so it's easy. I do not want to explain really how macros work because it's a bit hard. So what you can imagine, like if you have a tribal code string with Python code, and you somewhat put values inside that, like with templates or something like that, and then you execute the code like exactly. But it's not that unsafe, and it's easier to do because you can manipulate lists. These are basically lists instead of manipulating strings. So you don't have to work with regular expression if you want to perform things on the code. Okay, so that's why it is nice. This is a language extension basically. Okay. And this is how I can call them from Jython. Anyway. And this is the last method I want to implement in this object, which is find item. You see double diner before and afterwards. That is a method of by object we are overriding. And that is the one which Jython uses to have Python use the subscript operator, so to call things like that. When you write that in Jython, methods like these are called in underneath. Okay? So find item, I take this, I take an index, I convert the index to a number. If, for example, these are Python objects here, they are primitives, they're not numbers. So I perform the conversions. And then I pass the integer to the end function of the state attribute. So I get the end element of the list, which is not efficient because it's a list, but if it was a vector, it would have been quite efficient. But anyway, that is not about efficiency, it's just results. This is a try block because I want to catch the index out of bound exception I could get if I hadn't enough elements. And I convert it in an item index error exception.
Where is that exception trained from? Trained from Python, Clojure, or JVM? The index out of bounds exception.
That comes from Clojure. The Clojure runtime raises that exception. That is a Clojure function, basically. So this is an example. Clojure deals with index out of bound exceptions because it's nearer to Java. But in Python, we want index error exceptions, not index out of bound exceptions. So this is to make things easier for Java. Okay? And here we convert the object, because probably it is not a Jython object, into a Jython object. Okay? So that does the conversion. That is another thing which is important in the sense that in Clojure, Jython objects, Java objects are just Java objects. They are not wrapped in some super file, something like that. In Jython, we have to do that. Okay? And so there are those methods here, those functions. And we can just call things like this. If we haven't enough elements, that is an index error. If we take the wrong element, it's the type error, which comes from here. Okay? This is a Jython method, a Jython core function, and so it raises a type error. That is the right thing to do. This is bad, but this is how Clojure works. If you use n with just a floating point number, then it just makes a floor and uses that. Okay? But things up to now are very static. I mean, you just generate Java code and then you call it from Java. But we can do better than that. For example, we put Clojure code in a Python string. Okay? Then we can compile it. This code basically takes this string reader is like string.io. So we take the string, we make it a file-like object, and we pass it to compiler load. Compiler compiles the string, and then with this method here, star, we just get the variable. That is the namespace. That is the method. Then the symbol name we want to get. And so now, remember, contains the Clojure object, the Java object which represents the Java function. Okay? And we can invoke it because it's a Java object. And in Java we can call Java objects. So that is okay. This is just the basic on how to dynamically call Clojure code. We load it, we can read it from strings, for example. Okay? But it's not something we would like to use in real life, and so I thought about this. Well, I wouldn't advise anyone about using this in production code because it's a talk, but anyway, it's fun. Here we have the decorator and the Python function which contains in docstring Clojure code. So Clojure and Python are highly dynamic languages which have some nice features to somewhat extend the language and add things. So this thing basically works like, okay, I define Python functions in Clojure. And I want to call it like that. And it works, I mean. And I can also use help. No, I don't need help. I mean, anyway. And this is the decorator. So I just have to somewhat determine the namespace I want to put the function in. I will show you the function afterwards. But basically it just examines the dunder module, dunder attribute of the function. So it puts the function in a namespace which is named like Python module it was defined in. Then I build the Clojure function object. I get the docs and I put it here. And I build a wrapper function here, which is then updated to make the name of the function right, the arguments, everything. Okay? And I return it. So now, where is it? This render function is the out function which wraps the code to the Clojure object, which we build here, which we'll see in 2 slides. That is the term Clojure namespace, which is easy. We just see we have this variable, otherwise we use the user namespace. This is easy as well. We use some metadata. Clojure objects can have metadata, okay? And that's it. Here we build a Clojure function, which basically means just to define the namespace and put the Clojure code behind that, okay? Then we compile a thing which basically calls the Clojure load function we have seen a couple of slides ago. And then we get the Clojure object here, the Java object which represents the Clojure function here, and we return that thing, okay? So, I think it's nice because with just a few lines of Java here, we were able to put Clojure code to implement things in Clojure. I mean, perhaps you have a nice algorithm which you want to write in a very functional way using recursion, using lazy stuff, not Python generators, perhaps just functional code. But you want to work it with regular Python code. You just have to put the decorator on the function and implement it in Clojure. Of course, probably your boss is going to fire you if he finds out what you're doing, but I think it's very cool. Well, if he doesn't find it out. Anyway. Now we do the other thing. This is even nastier. I mean, that was easy. This is a bit more complicated here. We want to have Clojure call Jython. There is a typical problem when you have Java call Jython. Okay? Once there was a Jython compiler which compiled Python objects into Java class files. Now that is not supported anymore. And if you want to use Jython code in Java, The suggested method is just to build a Java factory, because in Java, whatever you want to do, you have to define a class or a bunch of classes doing that. So you build a factory, you have the Java object implement a Java interface, and then you have the factory load the Java code, execute it, and you have a create method in the factory, which creates the instance of the Java objects, and it casts that to the Java interface, and then you are able to use that. Of course, Clojure is dynamically typed, so it's going to work anyway. And this is an example of Python 5 here. What we do, we define an interpreter here, a Python interpreter that is Python stuff. We do an import from module name, import class name, okay? We execute that, and we get the object name plus name from the interpreter. So we have this variable here, main factory example dynamics, okay? Unfortunately, we still have to call the call method to get instances, because we know that Python classes are basically callables, which when called return the object instance. And since we have to use the explicit name, that is, and we have to do that in Java as well. I already see that in a few lines of Clojure that goes away. We have also to call this method because this is a Java object, and Py objects, constructors expect Py objects and arguments. So this has to be interrupted. And we can invoke the method like that. Okay? Now, this is quite more nice. Jump here, we just call make factory, spam an X. And then spam an X with just a number. Okay? This is quite more nice. We don't have all the call method stuff, the Py object conversion. We put it here in a function. Okay, so instead of returning tangent class objects, the tangent class object, which returns instances of the object, we return a Clojure function which wraps around the class instance. So we return this function, okay, which when called, calls call, and it passes the arguments, but we want them to be Java objects, so we call Java to Py on every argument. We convert that into an array and we pass it to the constructor, and that works like that. I have like 2 slides now. 3, perhaps. And still I'm not satisfied with this. I want to get this. Py class. I expanded the language. Now Clojure is able to interact with Python as a language feature. Py class example with something. You see, they are not strings anymore. They are just language. I mean, which is an action listener, which is a Java interface. And I can create things like this. Okay? And how I can do that? With that thing here, which is another macro. So I just get this thing, I convert it to a string, basically here, split the class name, the module name. I don't show that this because it's just Clojure string manipulation stuff, it's not very interesting to me. And I execute this thing, def symbol, class name, make factory, module name, class name, I convert it to strings, and I will also pass it JType. JType because now I want to call, that is like it was before, the same old function here. Okay? I call the toJava method with the interface, so the object which was created, each instance, is somewhat cast to the interface, to the Java interface. So that method now returns an object of type specified by the interface here. So in this case, action listener. And now we jump to the very first example. First, we did with proxy. So we had dynamically created objects called by the Swift framework. Now we have Python code. So we are calling in Clojure a Java framework which uses code written in Python. So we have basically three languages working all together. And so, what's good about that? Nothing. I mean, you are not going to use that in production right now. The point is that those examples, I basically showed you all the code. There is just a few details I skipped. I wrote them perhaps in 10 minutes each. I mean, that is something that if we want to do, we can do it. It's easy to do. Usually when you have interpreters or half interpreters like compiled languages, it's very hard to make them interact one with another. Because once we use custom virtual machines. Now we have some virtual machines which operate at a higher level. As I say, in this case, we work at Java object level, not at byte level, like if we were calling C code from one virtual machine to another. There is mono. There is LLVM. I mean, there are some. And if we just want to do this kind of things, perhaps that can be done. We can have different languages, completely different languages, work together quite nicely. I mean, this is Java, which is an implementation of Python, which has its story, whatever. Clojure, which was created to work with Java. And with a few lines of code, they're talking each other quite well. I mean, you can call Java from Clojure from Python, Python from Clojure. Thank you for your attention. This is the code if you want it.
Thank you, Enrico. And are there any questions?
I wonder about the performance of these translations from Python objects to Java objects to Clojure objects and back and forth and compiling stuff at runtime, etc.
So, Clojure is extremely efficient in the sense that Clojure always compiles things, even if it seems dynamic. So you write things in the wrapper, and it's compiled dynamically, and it's very efficient. Also, you can, I didn't show that, you can add type hints to Clojure, so it's able not to use Java Java reflection, okay? It just generates regular Java code. So calling a Clojure method, calling a Java method in Clojure is as efficient as calling that in Java. I would not like to say that Java is not as efficient, but that is my impression. That is to say, somewhat Java just uses reflection and that stuff, so it's a bit less efficient than regular Java code. Perhaps more than just a bit. But anyway, it's Python, we know that. But so, implementing things in Clojure, you can do that to get fast code. Python is Java.
Any other question?
Are there possible issues in the conversion of these things with some string types or some conditions which?
Plenty. I mean, this is quite experimental. I believe that if we have like 10 people who play with that kind of things, we should catch most errors and fix them, because it's not very hard. We are dealing with things at quite a higher level. It's not by stuff, you lose a bit somewhere, it's not like that. I mean, you have just the primitive types, and then you can fix them, and then you can restrict the domain, for example, things with uninterface defined. So you have Java type system which can come to help you. Just right now, these things is not tested. If really, you are going to be fired if you use this.
So, any other question?
Comment. I think this is a very interesting approach, and I've done a similar thing with JSON about 9 years ago. I had to interface JSON to an proprietary language of a workflow tool written in Java, and it showed very similar problems. And but it not well still product use today. So I think there's a way to go. It would be, I think it would be very good if what community and interested party would develop it further so it becomes a stable binding between the single languages. So I think it's a good job.
But that's in fact JSON merit. I mean, they did a wonderful job here in for example, Java to Py function and that stuff. It works very well. If I had to write them, I could not do it in a few slides. They are taking the strain of converting things, Java stuff into Python and vice versa, and this their merit. Without that, we couldn't do that. Clojure doesn't care.
Okay, one more question.